All right, everybody, today we're going to be doing the additional practice for dividing rational numbers. Let's start with number one. We also got to remember to start with the rules for when we are doing rational numbers and dividing them. First rule being, I'm going to try to use my pen tool here. Doesn't look like it's letting me. Oh, there we go. Our pen tool is acting a little funny today. Let's remember, first of all, when we're multiplying and dividing fractions, that we have certain rules about what the positive and negative numbers will be. And rule number one is a positive times a positive will equal positive. And a negative times a negative will also equal positive. The only time we get a negative is when we get a negative times a positive, or a positive times a negative. So let's begin. We got here a positive times a negative number. We know our answer is going to be negative. And then we have to remember the other rule: when dividing fractions, we use keep, change, flip. And for those that learned it in my class, you might have also learned it as KFC, finger looking good method, which allows us to keep the first fraction the same, flip the second fraction, and then change from division to multiplication. So if we do that here, we realize that we're going to have, this is going to be turned to multiplying negative 7 over 13. And now we have to multiply the top to the top, and 5 times 7 is negative 7. It's going to be negative 35. And the negative sign is already here, so we don't have to put the negative over here. Then 6 times 13, and 6 times 13 is going to be 78. All right, next let's go to number 2. It says simplify the complex fraction. Rewrite the complex fraction where every fraction is a division problem. So this is really 7 over 10 divided by negative 2 over 5. Now it says write it as a multiplication problem. Well, remember we can use keep, change, flip to turn that 7 over 10 and multiply it to negative 5 over 2. And the product of that will be, well, 7 times a negative 5 is negative 35, and 10 times 2 will be 20. Problem is, we know that 20 goes into 35, and let's go ahead and write that out. We know that that is going to give us, that will give us negative 35 over 20. 20 goes into 35 one time. So we know that we're going to have negative 1 and 15 over 20. And 15 over 20 can really be reduced because they're both can be divided by 5. That's going to give us 3/4. So our answer is going to be negative 1 and 3/4. There you go. We're down now to number 3. Use the division expression. 5 over 8 divided by 1/6. Write the equivalent multiplication expression. Well, that's going to be 5 over 8 times, you guessed it, 16 over 1. Remember, we flipped that second one. Now reasoning, how many times can 5 over 8 be divided by 1 over 6? Well, let's think about this. 5 times 16, that's going to give us 80, and 8 times 1 is 8. 80 divided by 8 is 10. So that means I can divide it 10 times. The product of the multiplication expression is 10. Number 4 says use the division expression, negative 10 over 13, divide 4 and 1/3. Divided by 4 and 1/3. Well, remember, we've got to take the second number, turn it into a complex fraction. 4 times 3 is 12, and 12 plus 1 is 13. So we're really going to go ahead, it says to write the expression multiplication of this one. That'd be negative 10 over 3 times, and we turn that into an improper fraction, since it would have been 13 over 3, it would be 3 over 13. And there you go. Now find the product. Well, we've got negative 10 times 3, that's negative 30. And 13 times 13, that's like 169. Yeah, so that's going to be negative 30 over 169. We're off to number 5 now. Number 5 says simplify the expression. It says here negative 3 and 1/6 divided by negative 1 and 4/9. We're going to have to turn these both into improper fractions. When I do this, I realize that I'm going to have, let's write this out over here. We're going to have 6 times 3 is 18 plus 1, that's 19. So this is going to be negative 19 over 6. And we're going to be dividing that by, well, 9 times 1 is 9 plus 3 is 13. So that's negative 13 over 9. And now we can go ahead and remember keep, change, flip. We'll keep the first one the same. And now we're going to, instead of divide, we're going to multiply by the inverse of negative 13 over 3, which is negative 9 over 13. I might have said 3, I meant to say 13. And now 6 and 9 we can see are both divisible by 3. So this would be a 2 and this would be a 3. Now I have negative 19 times 3 and 2 times 13. Well, negative 19 times 3 is going to give me, let's see, that it'd be 27 to negative 57. Actually, I have a negative divided by negative, so it'd be positive 57. And that's going to be divided by 2 times 13, which would be 26. And now I have to see how many times does 26 go into 57. Well, 26 times 2 will give me 52. So that means it goes into it twice. And there'll be 5 left over, because 57 minus 52 will be 5. And my answer should be 2 and 5 over 26. Let's see how Mr. Mendez did. 2 and 5 over 26. All right, number 6 says find the quotient. Again, we have a fraction with a decimal here. So what we first need to do is turn one of these into the same type of in either a fraction or a decimal. We're going to change it. I'm choosing to go ahead and turn this into a fraction. And here's why. I know that negative 3.4 is going to be negative 3 and something. I have to take that 0.4 and turn it into a fraction. My rule for fraction state, as long as there's not a line over it, I can get rid of the dot by putting a line under it and putting a 0 under each number there, and then putting a 1 in front of all the zeros that I make. Now that's 4 over 10, and that can be reduced to 2 over 5. And now I really have negative 3 and 2 over 5. And now I can go ahead and state that I want to take this one and turn it into an improper fraction. 3 times 5 is 15. 15 plus 2 is 17. So this is really going to be equal to negative 17 over 5. And now we can go ahead and keep, change, flip. We've got our 4 over 15. We're going to be multiplying it to 5 over 17. And right here I can see that 5 and 15 both, we can use the butterfly method. 5 goes into 5 one time, 5 goes into 15 3 times, and now I have 4 times 1, which is 4, and 3 times 17, that's going to be 51. So I believe my answer is going to be negative 4 over 51. Just guessing here, let's find out. Negative 4 over 51, look at that. All right, number 7 says, CJ says the quotient of negative 3/4 divided by 1/4 is 1/3. What is the correct quotient? Well, we realize that when he should have swapped this number upside down, right, the inverse, that would have given him 4 over 1. 3 times, well, we had a 4 on the top and 4 on the bottom then. They can be reduced out by dividing 4 into both of them, turning them into 1. So this is going to become 1 over 1. And now we have 3 times 1, which is 3, over 1 times 1. That's not going to be 1 over 3. That's actually going to be negative 3. What mistake did CJ make? I think he accidentally might have turned this one upside down. He multiplied using the reciprocal of negative 3/4. So I'm going to go with that. That sounds pretty much like what he did there. A said he multiplied the reciprocal of both fractions. If he did that, then he would have got the same answer. Let's see, he would have turned both of these upside down. That wouldn't have got him the correct answer. He added 3/4, and no, he did definitely not add these. And he multiplied by 1/4. No, he did not multiply that. That would have gave him 3/16. D is the only correct answer there. Number 8 says the complex fraction negative 8/11 divided by negative 3/5. It says to use that complex fraction, write an equivalent multiplication. Well, that's going to be negative 8/11 times negative 5/3. There we go. With the quotient of the complex fractions, will the quotient of the complex fraction be positive or negative? Well, we got a negative times a negative. A negative times a negative will definitely be a positive. So the rules for dividing rational numbers are the same as the rules for dividing integers. A negative value divided by a negative value equals a positive value. Last one, number 9, says explain why when dividing fractions with the same denominator, you can find the quotient by dividing the numerator. Support your answer with the example using one or more mixed numbers. Well, when I do this, I can say, let's see, explain. Okay, so basically what they're saying is, if I had two fractions, let's say like 3/4 divided by 1/4. Okay, they're saying when dividing fractions, we're dividing fractions with the same denominator. Both my denominators are the same. You can find the quotient by dividing the numerators. Why is this? Because when we do keep change flip, this is going to give me 3/4 times 4/1. And that means I'm going to be having 4/4, which is going to give me 1. That means I'm dividing my numerator by my other numerator, right? So 3 divided by 1 is simply going to be 3. Let's see what they got for an answer on that one. When the denominators of both fractions are the same, the quotient of the denominator is 1. That's right. When they're both the same, the quotient will be 1. So the quotient of the numerator is the quotient of the new expression, since any value divided by 1 is itself. Here's an example. Look, they get 3/4 divided by 3 1/4. When they did this, turn it into improper fraction, they realized this is 3 times 4, which is 12, plus 1, that's 13/4. Then they had to turn that upside down using keep, change, flip. So you had 3/4 times 4/3. And now you're getting rid of those 4s, just like I did over here. That's going to give you 3/13. Well, that was all of the work tonight. Hope that helped, and I will see you during the next lesson. Have a good one.